In this lesson, we're going to learn how to solve quadratic equations by factoring. First, let's begin by considering everything that we know about equations and their solutions. We know that a solution is a value or the values that make an equation true. Remember, an equation is two expressions connected with an equal sign, such as 3x plus 5 equals 11. X equals 2 is a solution to this equation because when we substitute 2 in place of x, we end up with an equation that is true, 11 equals 11, and we know that solutions are values that make equations true. Another word for a solution is root. So, a problem might ask you to find the solutions or to find the roots. These two statements are equivalent and mean exactly the same thing. Today we're going to look at quadratic equation. A quadratic equation is an equation that has a squared term. X squared minus 5 equals 4x is a quadratic equation because the highest power of any term is the second power, x squared. This equation has two solutions. One solution is x equals 5. X equals 5 is a solution since when I substitute 5 in place of x, I get a true statement, 20 equals 20. Another solution to this equation is x equals negative 1. Again, because when I substitute negative 1 in place of x, I get a true statement. So how do we find the solutions of a quadratic equation, an equation that has both x's and x squareds? Well, it turns out that we know everything we need to already in order to do this. Here's how we solve a quadratic equation. The first step is to make sure that the equation equals 0 and that the equation is written in standard form. If there are terms on both sides of the equal sign, you'll have to use the properties of equality to move everything to one side so that the equation equals 0. A piece of advice: do whatever you have to keep the x squared term positive. It will make your life much easier. Step 2 is to factor the polynomial. You may have a greatest common factor, a difference of two perfect squares, or a trinomial that you need to factor. Step 3, set each factor equal to 0 and solve. Let's take a look at some examples to see exactly how this works. In our first exercise, we have the equation x squared minus 5 equals 4x. We've seen this example already just a moment ago, and we know there are two solutions. So let's see how we find them. First of all, the equation must equal 0. This equation does not equal 0, so we must use the subtraction property of equality to subtract 4x from both sides. Write your polynomial in standard form. X squared minus 4x minus 5 equals 0. Now that the equation equals 0 and the polynomial is in standard form, we can begin the process of factoring. If you need help with factoring, I recommend going back and watching the videos on how to factor. We want numbers that multiply to negative 5 and add to negative 4. Those numbers are negative 5 and positive 1. Because this trinomial has a leading coefficient of 1, it's very easy to factor this to x minus 5 times x plus 1 equals 0. Of course, if need be, I could always use the grid to obtain those factors. Once you have the factored form of the equation, it's time to find the solutions, or the roots. We have two factors, x minus 5, so we write x minus 5 equals 0, and x plus 1, so we write x plus 1 equals 0. We solve each of these little equations. On the first one, we begin by adding 5, and that gives us our solution, x equals 5. In our second equation, we subtract 1, and we end up with x equals negative 1. That's the second solution. You could write them as x equals 5 or as x equals negative 1, or if you choose, you could write these as a solution set using roster notation. If you do choose to write it as a solution set, remember that the numbers go from smallest to largest. And now we've found the solutions to the equation. Let's take a look at another example. In exercise 2, we have x squared equals negative 2x plus 15. Remember, the equation must equal 0, and we want to keep the x squared positive. So we'll add the 2x to both sides and subtract 15 from both sides. See if you can set this equation to 0 and then factor the trinomial that results. Then see if you can find the solutions to the equation. Please pause the video here and come back to compare answers when you're ready. Let's compare answers. We know that the equation must equal 0, and so we begin by adding 2x to both sides and then subtracting 15 from both sides. Written in standard form, we have x squared plus 2x minus 15 equals 0. Because our equation equals 0 and our trinomial is in standard form, we know we're ready to begin factoring. We're looking for numbers that multiply to negative 15 and add to 2. Those numbers are 5 and negative 3. Because the leading coefficient is 1, it's very easy to take the numbers and write the factored form. X plus 5 times x minus 3 equals 0. Of course, if you wanted to, you could always find the factors by using the grid. Now that we have the factored form, we're ready to find the solutions. We take each of the factors, x plus 5, and set it equal to 0, and x minus 3, and set that equal to 0. On the first equation, we subtract 5 from each side, and we have x equals negative 5 as our first solution. In our second equation, we add 3 to each side, and we have x equals 3 as our solution. This equation has two values that make it true, x equals negative 5 and x equals 3. Remember, you could write this using set notation as follows with the squiggly brackets, negative 5, comma, 3. So far when we have solved our quadratic equations, our solutions have always been integers, but they could also be fractions. Take a look at this equation. Exercise 3 has 15x squared equals negative 7x plus 4. We want to find the numbers for x that make this equation true. The first thing we know is that the equation must be equal to 0 and that we want to keep the x squared positive. X squared is positive where it is, so we'll add 7x to both sides and subtract 4. Now we have the polynomial 15x squared plus 7x minus 4, and that is equal to 0. Now that our equation is equal to 0 and the polynomial is in standard form, we're ready to factor. We need numbers that multiply to negative 60 and add to 7. Those numbers are 12 and negative 5. But this time our leading coefficient is not 1, and so I'm going to go and use the grid. I'll put my 15x squared in the first box and the minus 4 in the last box. I put the 12x and the minus 5x in the others, and I look for the greatest common factor across the top and then use multiplication to fill in the remaining spots. The factored form is 5x plus 4 times 3x minus 1 equals 0, and the process is exactly the same. To find the solutions or roots of the equation, I take each of those factors and set them equal to 0. So I have 5x plus 4 equals 0, and 3x minus 1 equals 0. Now we solve. In the first equation, we subtract 4 from each side using the subtraction property of equality, and then divide each side by 5 using the division property of equality. X equals negative 4/5 is the first solution. Notice it's not an integer. It's a fraction this time. In the second equation, we'll use the addition property of equality to add 1 to each side, and then we'll divide each side by 3, giving us x equals 1/3. Our second solution is x equals 1/3. If you choose to stop right there, that's a perfect place to stop. That's how I write my solution. Or, if you prefer, you can write your solution set using roster notation. Here's another exercise for you to try. 3x squared minus 10x equals 25. Remember the first step, we have to make sure that the equation equals 0. Please pause the video here, solve this equation, and return when you're ready to compare answers. Let's compare answers. We need the equation to equal 0, and we want our x squared to be positive. The x squared is positive where it is, so I begin by subtracting 25 from each side of the equation using the subtraction property of equality. 3x squared minus 10x minus 25 equals 0. Now that my equation equals 0 and the polynomial is in standard form, I can begin the process of factoring. Numbers that multiply to negative 75 and add to negative 10. Those numbers are negative 15 and 5. Because my leading coefficient is a 3, we need to use the grid to factor. When I factor using the grid, I have the factors x minus 5 times 3x plus 5 equals 0. That's the equation written in factored form. I'm now ready to find the roots, or the solutions, to the equation. We take each factor and set that factor equal to 0. Now we solve each of those equations to find the solutions. X equals 5, and x equals negative 5/3. It's best not to convert that fraction into a decimal. If you do, you'll likely round your answer, and therefore it would really no longer be a precise solution. Best to stick as a fraction. Remember, if you choose, you could write this solutions using a solution set using roster notation, where the smaller number comes first and the larger number comes second inside of the squiggly brackets. Let's look at another quadratic equation. This one looks a little bit different. 5x squared equals negative 3x. We follow the same process. We know that the equation must equal 0. We want the x squared to be positive, and 5x squared is positive exactly where it is. So my first step will be to add 3x to both sides and to write the polynomial in standard form. Now that we have our polynomial in standard form on the left and our equation equals 0, we can begin the process of factoring. But this time I don't have a trinomial. This time I simply have a binomial, which has a greatest common factor. That greatest common factor is x. So my factored form of the equation is x times 5x plus 3 equals 0. Now that I have my factored form and the equation equals 0, I'm ready to find the solutions, or roots, to the equation. I begin by writing each of the factors equal to 0. The first factor is x, so I write x equals 0. The second factor is 5x plus 3, so I write 5x plus 3 equals 0. And now I solve each of them. The first one, x equals 0, is already solved, so I have the first solution to the equation. The second one, I have to subtract 3 from both sides, and then divide both sides by 5. That gives me x equals negative 3/5. The solutions, or roots of this equation, are x equals 0 and x equals negative 3/5. Remember, these are the numbers that if you substitute them into the equation will be true. If you choose, you may opt to write the solution set using roster notation. If you do, you would write in the squiggly brackets, negative 3/5, comma, 0. It's simply a list of the solutions. Exercise 6 is for you to try. Here we have a quadratic equation that is already equal to 0. We're ready to factor. Take a look at x squared minus 49. See if you can factor that and find the solutions to this equation. Please pause the video here and come back when you're ready to compare. Let's compare answers. We have a difference of two perfect squares, x squared minus 49. We factor the difference of perfect squares to x plus 7 times x minus 7 equals 0. Now that we have the factored form and the equation is equal to 0, we're ready to find the solutions, or the roots, to the equation. We take each of the factors, x plus 7 and x minus 7, and set them equal to 0. We solve to find x equals negative 7 and x equals positive 7. These are the solutions to the equation, the values that will make the equation true. Notice this time we have a positive 7 and a negative 7. It's the same number, except one is positive and one is negative. There is an optional way you can write this. X equals positive and negative 7. Either way is fine. And of course, if you prefer to write using set notation, you could write the roster notation for the solutions to the equation. Let's end today with one last exercise. Here we have an equation, 7x squared plus 49x plus 70 is equal to 0. First thing we need to do is make sure the equation equals 0. It does. We're ready to go. And our trinomial is in standard form. This time there's a greatest common factor to factor out. Please pause the video here and see if you can find the solutions to this equation. Let's compare answers. We begin by factoring out the greatest common factor of 7. That leaves us in the parentheses x squared plus 7x plus 10. We have a trinomial. We can factor that by looking for the numbers that multiply to 10 and add to 7. Those numbers are 5 and 2. Because our leading coefficient of the trinomial, x squared plus 7x plus 10 is 1, we can go right to factoring, or if we want to, we can use the grid. Either way, your factors will be 7 times x plus 5 times x plus 2. Don't forget, that equals 0. Now that we have the factored form and the equation equals 0, we're ready to find the solutions or the roots. We have 3 factors this time, so we write each of them equal to 0. 7 equals 0, x plus 5 equals 0, and x plus 2 equals 0. 7 equals 0 makes no sense, so that's out. There's nothing there for us. X plus 5 equals 0, we solve that, and we have x equals negative 5, our first solution. X plus 2 equals 0, we subtract 2 from each side, and we have x equals negative 2. So we now have the 2 solutions to our quadratic equation, x equals negative 5, and x equals negative 2. Remember, these are the values that make the equation true. If you prefer, you could write this as a solution set using roster notation. And so now you know how to solve quadratic equations by using factoring. Remember, you can learn more about factoring and about quadratic equations in Mr. Dorey's Algebra Handbook.